In this video, we will be solving a question on confidence interval. For more on this topic, you need to subscribe to this channel. We are given a question here with observation from the normal distribution, and we are asked to derive the formula for a 100% multiplied by 1 minus alpha percent confidence interval for the mean. Solution. One, we should recall that for the sample mean, and distribution, we note that x bar is equal to 1 all over n summation xi's. And for each xi's, we will have that x bar follows a normal distribution of mu and sigma squared all over n. So this x bar follows a normal distribution of mean and sigma squared all over n. Then number two, to standardize the sample mean. To standardize the sample mean, to derive the confidence interval, we'll have that z is equal to x bar minus mu all over sigma squared all over n, where z follows a normal distribution of 0 and 1. So for we to derive the confidence interval, we need to standardize the sample mean. Standardizing the sample mean will have this. Also, 3, to construct the confidence interval, what we need to do is that we need a critical value. To construct a confidence interval for a 100 multiplied by 1 minus alpha percent confidence interval, we need a critical value. And that critical value, our critical value is, say, z alpha all over 2. Z alpha all over 2. So the next thing to do is to now write it in this form. P is equal to negative z alpha all over 2 is less than equal to z, this z, and is less than equal to positive z alpha all over 2 is equal to 1 minus alpha. Then this can be rewritten to give us P negative z alpha all over 2 is less than equal to z. We have it as x bar minus mu all over sigma squared all over n is less than equal to z alpha all over 2 is equal to 1 minus alpha. Nothing has changed, because what happened is that this our sample mean, which we want to use in deriving the confidence interval, is this, and this z is also equal to this. So the next thing to do is to divide through by this. So we come over to this place. First, we are talking about when this is known. So multiplying through by sigma all over square root of n, we get, if we multiply through, we get this multiplied by this. So we have something like p negative z alpha all over 2 multiplied by sigma all over square root of n is less than equal to, of course, if we multiply it with this, it can cancel this. So we have x bar minus mu is less than or equal to z alpha all over 2 multiplied by sigma all over square root of n equal to 1 minus alpha. So this is what we have. That means the confidence interval for mu, will be, this will come over to this place to give us x bar minus z alpha all over 2 sigma all over square root of n is less than or equal to mu and is less than or equal to x bar plus square root of n. So this is what we get. That means 1. If sigma squared is known, we have our function to be x bar minus z all over 2 sigma squared all over n and x bar plus z alpha all over 2 sigma all over square root of n. More so, if sigma squared is not known, it means we need to translate what we have to the t-square distribution. So translating this to the t-square distribution, if sigma square is not known, what we do, we translate to t distribution. So for the t distribution, with n minus 1 degree of freedom, we can say let z be equal to t, and our sigma squared or our sigma will be equal to our standard deviation. So we have from this, we have from that, we can write it as x bar minus our z alpha all over 2 n minus 1 degree of freedom. This z, like we said, will now turn to t. This z will now turn to t. It will now turn to t. Since we are translating it to our t distribution. And we are supposed to have sigma all over n. It will not be s all over square root of n. And we now have x bar plus our t all over 2 n minus 1 degree of freedom, our standard deviation all over square root of n. So this is what we have if we are changing it to degree, the t distribution. So when the variance is not known, we have something like this. And when the variance is known, we have this. So this is how we can compute the confidence interval. For more on this topic, you need to subscribe to this channel.